Hi, welcome back to Moose in Chemistry. This is pH Problems Lesson 2. Okay, so here what we're going to do is we're going to determine two problems today. One is going to be like the one we did in Lesson 1, but the other one is going to be a little bit different, so you're going to want to really pay close attention to that one. So now we look at this. It says determine the hydronium hydroxide ion concentrations in a solution that is 3.0 times 10 negative 2 molarity NaOH. So we're looking at the base. All right, so remember that our Kw constant, we'll drop the Kw part. So we have H3O plus OH negative, okay, equals 1.0 times 10 to the negative 14 m squared. All right, so in this case, we're going to plug in for the OH. So our OH value is 3.0 times 10 to the negative 2. And we have 1.0 times 10 to the negative 14 m squared. So we'll put a little m there. All right, so now what we're going to do is we're going to isolate for the hydronium ion. And here we go. 1.0 times 10 to the negative 14 m squared divided by 3.0 times 10 to the negative 2 m. So our m's will cancel out for sure. And this is going to give us 0.33 times 10 to the negative 12. Well, you know what? That's not proper scientific notation. So we're going to move it over 3.3 times 10 to the negative 13. And that's our first problem. So again, like the problems we did in the lesson 1, it's all the same. But now let's look at something a little bit different. So I'm going to go ahead and clear all this problems and drawings real quickly. And I'll be right back. Okay, here's our second problem. It says determine the hydronium hydroxide ion concentration in ion solution that is 1.0 times 10 negative 4 molarity CaOH, calcium hydroxide. So, the number looks the same, but wait a minute, there's something different about our OH ion. What is it? What is different? Oh, look, we have two of them. So whatever number we have, this 1.0 times 10 to the negative 4, we're going to have to multiply that by 2. All right, so that's going to be the big change here. All right, so let's go ahead and write our Kw constant first. So we've got H3O plus OH negative equals 1.0 times 10 to the negative 14 m squared. So that's our standard Kw constant. All right, but before we can plug in this number that we want to put here, we have to do something else. We're going to have to multiply it by 2 because of that 2 right there. So take a good look at that, and we'll clear it. All right, so we're going to go 2 times 1.0 times 10 to the negative 4 m, which is going to give me 2.0 times 10 to the negative 4 m. So now that equals our CaOH 2 because we have 2 of those. Okay. So now we can put it into our Kw constant problem. Okay, and here we go. So we're going to go H3O plus. And then we're going to go 2.0 times 10 to negative 4 m. What if we had a 3 there? Then I guess you would use 3. So let's do 1.0 times 10 to the negative 14 m squared. Okay. So H3O plus equals 1.0 times 10 to the negative 14 m squared divided by 2.0 times 10 to the negative 4 m. Well, that's going to cancel out, and that's going to cancel out. And this is going to give me 0.5 times 10 to the negative 10 m. And that's not proper scientific notation, not in any stretch of the terms. So we're going to have to move it over 1, the decimal 1 place. So we'll make this 5.0 times 10 to the negative 11 m. Okay, that's pretty cool. And so that's it for today, and I hope you guys have enjoyed this lesson. You guys be awesome, and we'll see you back here at Moose in Chemistry.